Assalamualaikum and very good morning to Dr. Muhammad Rashidi. My name is Muhammad Aikam bin Ahmad Muzailan from Microelectronic Year 1. Matrix number 2410126865. Today I'm going to present about power MOSFET. What is MOSFET? MOSFET stands for Metal Oxide Semiconductor Field Effect Transistor. Is a semiconductor device which is widely used for switching and amplifying electronic signal in the electronic device. So what is power MOSFET? The power MOSFET are very special to handle the high level of powers. It shows the high switching speed and by comparing with the normal MOSFET. The power MOSFET will work better. The design of power MOSFET was made by using the CMOS technology and also used for development of manufacturing. As you can see, the diagram for power MOSFET, this is the, what we call it, symbol or component that got in power MOSFET. There is two types of power MOSFET, enhancement types and depletion types. For enhancement type, the transistor requires gate source voltage to switch the device on. The enhancement MOSFET is equivalent to a normally open switch. For depletion types, the transistor also requires the gate source voltage to switch the device. But for off, the depletion mode MOSFET is equivalent to a normally closed switch. As you can see on the slide, I also put symbol for enhancement type. Figure 1 on the top one. For the bottom one, for depletion type symbol. Based on the slide, uh, I include the example figure for depletion type MOSFET. A depletion type MOSFET is a type MOSFET that is normally on by default. It can conduct current between the source and the drain even when no voltage is applied to the gate. To turn it off or reduce the current flow, a voltage of opposite polarity to the channel type is applied to the gate. Advantages of depletion types. It can operate as a normally on switch without additional gate drive voltage. Also, useful in fail-safe application where default connection is required. For disadvantage, depletion types, higher static power dissipation when the device is on. Limit availability and less common compared to enhancement MOSFET. An enhancement type MOSFET. Enhancement type MOSFET operate in a normally off state. This means no current flow between the source and drain when no gate voltage is applied. A positive for N channel or negative for P channel. Gate voltage must be applied to create a conductive channel and turn the device on. Advantages of adjustment types. Got low power consumption when in off state. Also high input impedance leading to minimal current draw at the gate. Suitable for fast switching and high frequency application. There's a lot of operation of power MOSFET, but I only include 3 operation. First operation, key region of operation. Second, gate control mechanism operation. And last, reverse operation. Operation of MOSFET, key region operation for cut-off region. Operation, no current flow between the drain and source. For linear ohmic region, operation, the MOSFET behaves like a resistor and the drain current is proportional to VDS. For reverse operation, power MOSFET include an intrinsic body diode between the drain and source which conduct current in reverse polarity when the MOSFET is off. It's useful in application like synchronous rectifier. For gate control mechanism, voltage control behavior. A voltage applied to the gate terminal control the formation of a conductive channel between the drain and source. Insulated gate. The gate is insulated from the channel by a thin oxide layer, ensuring minimal current draw at the gate. For the summary of basic operation, a power MOSFET operates by controlling current flow between the drain and source through the gate voltage. It acts as a fast, efficient switch or variable resistor in various applications, offering high efficiency and precise control in power electronic circuit. For characteristic of power MOSFET, in the slide I only include two characteristics for power MOSFET. First, thermal characteristic. Junction to ambient thermal resistance. The resistance to heat flow from the MOSFET junction to surrounding ambient environment. It can improve heat dissipation. Second point, maximum junction temperature. The maximum temperature the MOSFET internal junction can withstand typically range from 150 Celsius to 175 Celsius for silicon device, higher for wide bandgap material. Second characteristic is performance characteristic. Safe operating area, or we can say SOA, define the range of voltage and current MOSFET can handle without damage. SOA include continuous and pulses operation limits. Second point, efficiency. High efficiency due to low RDS and minimal switching losses. Suitable for application require high power density. Future trend in device development and application for power MOSFET. Future trend for power MOSFET electrification of transportation. The electrification of transportation, particularly in electric vehicle like EV and hybrid electric vehicle and electric power public transport system, is driving the demand for advanced power electronic. Power MOSFET play a critical role in this transition thanks to their high efficiency, fast switching, and reliability. They are also used in traction inverter for DC converter and battery management system. Their priority focus is on high reliability device for automotive standard. Power MOSFET with lower conduction losses to enhance vehicle range. Second future trend in power MOSFET is for smart MOSFET with integrated intelligence. Incorporation of features like real-time sensing, diagnostic, and protection within MOSFET. Their capabilities are monitoring temperature, current, and voltage. They also capabilities for overload and short circuit protection. For application, they are smart grids and IoT enabled device and predictive maintenance system. So for the question for power MOSFET, power MOSFET has become irreplaceable in modern power electronics, especially when high efficiency, fast switching, and precision are required. Their basic characteristics are low on resistance, high operation speed, and thermal robustness, extending their field of application to very diverse industries such as automotive, renewable energies, consumer electronics, and industrial automation. With the ever-growing demand for energy-efficient and compact power solution, power MOSFET will continue to play a very important role in shaping technologies that drive innovation in electrification, sustainability, and connectivity. Okay, that's all from me. Thank you for watching.